Hello! In this video, I'm going to demonstrate how to use Gephi to analyze a standard network. Now we open the software by double-click it. It takes 7 minutes, no, 7 seconds. It depends on how fast your computer is. And then we do the new project. And we need to open the data, which is saved in a spreadsheet, recording all the ages. Mine is a political book network, which is undirected. That's why I'm choosing undirected. And hit a new graph, hit OK. Okay, it's loaded because we here have a graph selected to be the shown. Okay, you can see this is the nodes, the links. It's not quite very well, so let's give it some color. And we need to choose a rank parameter. Now we choose degree. This color looks good. If not, we can go to here and select whatever you want. Let's choose the green and try how it look like. Hit apply. Okay. I like green. Okay, and then this is size. Sorry, my computer. This is too small. Which means the node size will be 1 to 100. What about 300? Let's try. Oops, too big. Let's go back to maybe 150. 50. Okay, apply. Oh, something wrong here. Oh, maybe just to go to 100 or 70. How's that? Oh, looks good. Okay, and let's. I think we need to show how the algorithm. So the layout algorithm, let's try the Frenchman Rico, and we need to run in order to display. Okay, this is optimizing. The software is trying to find out the best layout. Okay, we'll wait for it stop running, and it looks good. Now hit stop. And we can go to the preview to see it. We need to hit refresh. It looks good. So it's good for output. If you want, we can go to snippet. This is snipping tool. It's good to make a screenshot. Like new and choose it. Okay, and then you can save it for later demonstration. So I just put it on the desktop and name the show. Okay, and we can close it. And we can go to overview, do some statistics, and here on the site we can choose statistic, and we want to hit the run for whatever you want to see. So this is average degree. We can close it because the data is already saved in the data laboratory, and we might want also network diameter, not normalized. Yeah, looks good. Okay, and close. For maybe we can go to the page rank. Okay, we want the data, and this is the distribution, and maybe clustering coefficient undirected is okay. Now you can see the result is already here, and average path length, yes, Modularity, this is good because we want it for communities. And close. And average weighted degree, maybe we need it. Maybe not. Anyway, we get all these running, and then we can, eigenvalue, we need this one. Run. Number of iterations until it looks good. Okay. If we want the data, we can go to the data laboratory. And here's all the calculated value by nodes. And we can, in order to analyze them further, we can export to in order and save it. So we can give it another name, maybe table 1. Okay, save it with success. Okay, so we can go to the Excel later to do some analysis, but now for demonstration for the Gephi, we'll continue. So if we want to show a network layout depicting the trade-off and the correlation between the closeness centrality and the betweenness centrality, we can go back to the overview, and then we can choose closeness centrality. Do we have that? Yes. And we can show it with color. And let's choose another color. Maybe it's red. If the color is lighter, means the centrality is small. But it's darker means it's bigger. So let's apply. So we can see this darker color meaning they have a better centrality. And then for the another expression, we can have on the other feature like betweenness, and then maybe size still 70, so 70 is okay. Okay, and hit run. Now it changed. Well, the nodes with the bigger size had bigger betweenness. We can see the nodes with higher betweenness are located in the middle of the graph somewhat. So this makes sense. So if we want to have a better view, we can go to the preview, and this is the previous layout. We need to refresh it. Okay, so this is the output of the layout of the correlation of the betweenness and closeness centrality, which is number 3 of my assignment. Let's do another one. How about the number 2 of my assignment, which is a layout showing the trade-off and the correlation between node degree and the local cluster coefficient. So basically, we can go to the nodes and choose 2 parameters, one for color and another one for the size and weight, and see how it play out. So we can go to we can choose the first one, node degree and play it with color. This time we show another color, just green again, and then click apply. This is the degree, and then we can choose another parameter, which is local cluster coefficient. It should be this one. Okay, and hit apply. Okay, it changed. Because this is showing a different relationship. And we go to the preview and hit refresh. Okay, this is the layout depicting the color depicting the degree of the nodes, and the size of the nodes decree the local cluster coefficient. So you can see the degree in the middle is bigger, and we can see there's more links, edges connecting the darker vertices. And for the local clustering, it is spread out, and typically on the boundaries, it has more centered clusters. Okay, and let's do another one, which is the number 4 of my assignment, which is different, depicting the communities and the eigenvector centralities. So we can go back to overview and choose different parameters for, we highlight the nodes, the color, and then we choose the parameter to be communities. It should be modularity class. It's just a different name. Okay, go to another color, apply. Okay, and then go to the eigenvector centralities. Get all the output here. Okay, and we choose the size. Hit apply. Okay, so this is the apply. The icons are too small, so sometimes I cannot hit it. And we can go to the preview, refresh. Okay, this is awesome. From this, we can see the eigenvectors, which is the size of the nodes. We have two groups, big eigenvector groups. One is on the upper bound, and another is on the lower middle. So, and for the color, the darker is we choose the community. So the darker color means better communities, larger communities. So this is pretty cool, and it's very good visualization, and this is a very good experience. Okay, thank you. That's for today.